Hello everybody! Now it's been a while since I've recorded my last video, so I may be a little bit rusty, but we're going to get through this just fine. So today's topic is going to be Raycasts, and I'm going to approach this in a little bit different way than I usually do, because we're going to do it with simple graphics. So what that means you're going to see right now. So as you can see, I'm an absolute genius when it comes to drawing stuff. So that's the reason why I've become a programmer and not an artist. But raycasting is a topic that really benefits from a kind of visual approach when you're getting to teach about it. So I decided to do it anyways, and maybe it'll be fun for you guys. So raycasting is something that this extremely beautiful picture describes already a little bit. Raycasts means something like, you can imagine like an eye looking at something and then determining what it sees. That's something that you need quite often in computer games. Imagine you have a player and you want to know what's in front of the player. So you can determine if you need to punch it or if you pick it up, or I don't know, if you want to pet it because it's a cat or something like that. And that's what raycasts are used for. So this should be an eye, and it kind of just looks at something, and you can then do whatever you want with what it looks at. So I've prepared another beautiful slide here. Okay, so let's imagine this. We have a game where the player can hold a laser pointer, and this laser pointer analyzes what he's looking at. So in the programming jargon, let's just say whatever the player looks at is saved in a variable. So let's say the player first looks at this little girl down here, then the current target should be girl. All right, because he's pointing the laser pointer at her feet. He's barely hitting her. And that's something that you can only do with raycasts, or which raycasts are actually used for. Now that's already quite convenient, and with that we can already do quite something. So for example, with this simple tool we can determine if the player is standing in front of a treasure chest, and if he's in front of a treasure chest, he should open the treasure chest. But if he's in front of an item, he should pick up the item. Or if he is in front of an NPC, he should talk to the NPC. So depending on the context in what the player... depending on what the player sees in front of him, we can call, for example, a different function or something like that. That's what raycasts are really for, to determine what the player is standing in front of and act accordingly. Right, now let me show you how this works a little bit more in depth. Now let's say he's back at the start again. Now he wants to look at the enemy. So he shoots this beam kind of into this direction. And he's aiming for the feet for some reason, because he's a noob probably. And now we have a few important things how raycasts work. Now the first thing you need to know is raycasts always have an origin. They have a starting point. Now let's say this is the origin. And the starting point, let's say it's at 0, 0, 0. So it's at, this is just the origin of the scene, and it's also the origin of the shooting position of this raycast. Now, in order to determine where it should go, it also needs a direction. So this is the ray direction. Just say there. And this direction just goes to the right. So on the x-axis it's 1, y 0, and z also 0. So it goes to the right, and in theory it would go right until infinity, until it hits something. This is like a laser beam. It travels immediately, and it travels as long as it's not hitting something. However, in this case, the ray is of course hitting something, because here is a wall. Now, this is another very important thing for raycasting, because this is a ray hit, because it hits the wall. And if you shoot a normal raycast, it doesn't go into infinity, so these things are no longer valid. It stops here because it's already hit the wall. And the current target is the wall. It's not the enemy, it's the wall. Okay? So it stops here. And this ray hit usually also has the exact position where the hit occurs. In this case, I don't know, let's say it's at 7, 0, 0, for example. So this is 7 meters to the right of the player. And with this, we can already do so many things. So we have now the exact position where the hit occurs, and we know what is being hit. So with this information, we could, for example, if this was a weapon, we could spawn a bullet hole if the player shoots here. So these are things that are quite nice to use, okay? Right, now there's one more thing you should know about raycasting. I already said they usually stop at the first thing they hit. But there's a separate method that goes through everything and checks for everything that's being hit. So instead of shooting a normal raycast, you can shoot like a raycast that goes through everything. And then the current target is the wall and the enemy. So you have an array of objects that are being hit, because there could be 20 things behind this. And that's also something you sometimes use because it's quite convenient for stuff. Okay, now that's the basics of raycasting. It's used very, very widely. And you need a solid understanding of how vectors and directions work in order to understand in order to use them properly in Jest, okay? Good. Now, this is a very theoretical example, and yeah, it's not exactly how it works in Unity, but if you get this idea, if you get the theory behind it, it'll be much easier to understand the code that's going to happen right now.